Welcome to the AI Innovation Podcast, the signal in the noise of the digital frontier. Today, we are diving into a story that isn't just an incremental update, it's a fundamental change in the recipe for building intelligence itself. We're talking about Kimi K2 and a breakthrough that solves one of the most expensive, frustrating, and progress-killing problems in all of artificial intelligence.
So let me ask you something. Forget about data scarcity or compute limitations for just a minute. What is the single biggest technical threat holding back the next generation of AI? I'm talking about AI that can truly act and reason on its own, what we call agentic AI. This isn't some philosophical debate. It's a cold, hard, and incredibly expensive engineering problem.
The answer is instability. Just imagine this for a second. You're spending millions of dollars and weeks of dedicated GPU time training a massive new model, only for the entire process to just collapse. Catastrophically. All that time, all that money, poof, gone in an instant. And this isn't some rare glitch, it's a billion-dollar problem that has been a silent barrier to progress for the entire industry.
Now, what's really fascinating is where this problem comes from. It's a phenomenon called exploding attention logits. Okay, the simplest way to think about it is this. Imagine the AI is a high-performance engine, and the logits are the pressure gauges for its internal calculations. Well, when they explode, it means those gauges are redlining so violently that the entire system literally tears itself apart. And here's the deep irony. This often happens when you're using the most efficient training methods. The very tools designed to go faster were also the most likely to blow up. This is where the Kimi team introduced their game-changing solution, MuonClip. It's not just another algorithm, it's this incredibly elegant fusion of two powerful ideas. It takes the amazing speed and efficiency of the Muon algorithm and integrates a brilliant new stability mechanism called QK-Clip. This, right here, is the innovation that finally tames the unstable beast of AI training. And the results of this newfound stability? They are absolutely staggering. With MuonClip providing a rock-solid foundation, the Kimi team was able to pre-train their K2 model on an unprecedented 15.5 trillion tokens of data. Just let that number sink in for a moment. That kind of scale for a single continuous training run was basically unheard of, and it was only possible because they had completely solved the instability problem.
But here's the most remarkable part of the story. Over that entire 15.5 trillion token run, there were exactly 0 loss spikes, 0 catastrophic failures, 0 costly resets. A perfectly smooth, predictable, and flawless training process at a scale once thought impossible. This wasn't just an improvement, it was a demonstration of complete control. It's like turning AI training from a high-stakes gamble into a reliable engineering discipline.
So how in the world does it work? Let's go back to our high-performance engine analogy. Think of QK-Clip as a revolutionary high-tech fuel stabilizer. But instead of just flooding the whole engine, it works with surgical precision. Imagine an 8-cylinder engine. QK-Clip is like having a tiny, smart injector on each individual cylinder, applying the stabilizer only when that specific cylinder shows signs of knocking. That's what per-head basis means. It stops the pressure from ever exploding without messing up the smooth operation of the rest of the system. It's a minimal intervention with a profoundly powerful effect. So, here's the crucial point. Solving instability wasn't the final destination. It was the launchpad. It was the key that unlocked a whole cascade of other innovations. With a rock-solid foundation, the Kimi team could finally focus on the next frontier, data efficiency. The question became, how do you squeeze every last drop of intelligence out of your training data? And their answer is this brilliant knowledge refreezing pipeline. See, instead of just showing the model the same high-quality data over and over again, which risks memorization instead of real learning, they used an AI to synthetically rewrite the data. It's like, instead of rereading the same textbook 10 times, you get to read 10 different books on the same subject, each explaining it from a new angle. This creates a much richer, more diverse, and more profound training signal from the exact same source material. And the data does not lie. Just look at these results. Training on the raw data for 10 full cycles, or epochs, gets you to about 24% accuracy. But training on 10 unique rephrasings for just a single cycle pushes that accuracy up to nearly 29%. This is undeniable proof that the model learns faster and more deeply from varied perspectives than from just brute force repetition. It's all about the quality of exposure, not just the quantity, unlocking a whole new level of data efficiency. Before we dive into the next paradigm shift, make sure you secure your front row seat to the future. Visit us right now at AIinnovation.com.
Okay, so now we have a perfectly stable model trained on hyper-efficient data. What that gives us is a base model with incredible knowledge. But a library, no matter how vast, can't actually do anything. The next phase is about giving this powerful brain hands, transforming this library of information into a true autonomous agent that can perform tasks in the world. So how do you teach a model to act? Well, you create a virtual world for it to practice in. This isn't just about generating data, it's about building a digital flight simulator for AI. The Kimi team first built a massive universe of over 23,000 real and synthetic software tools. Then they generated thousands of unique agent personas with specific goals and complex tasks to solve. And finally, they simulated millions of missions recording every single successful action. The result is a massive, detailed playbook of how to get things done. And to learn from that playbook, they used a brilliant dual reward system. For objective tasks, like math or coding, the model gets a verifiable reward. Did the code pass the unit tests? It's a clear yes or no. But for subjective tasks, like creative writing, it uses a self-critique rubric. The model actually learns to judge its own work against a set of desired qualities. So it's learning not just what is objectively correct, but what is subjectively good. It's learning both the rules of the game and the art of the game. And they layered on even more sophisticated techniques to fine-tune the whole learning process. Budget control teaches the model an economy of expression. Be correct, but also be concise, a crucial skill for any useful agent. PTX loss acts as an anti-amnesia mechanism, making sure that as the model learns new skills, it doesn't forget the foundational knowledge it was built on. And temperature decay carefully manages the balance between exploring wild new ideas and perfecting the strategies that are known to work, giving you both creativity and reliability. So after all of this, the stable training, the data rephrasing, the agentic synthesis, and the advanced reinforcement learning, what's the final result? The ultimate payoff is a model that doesn't just inch the industry forward, but takes a giant leap, redefining the entire frontier of AI capability. Let's look at the numbers. In the absolutely crucial domain of software engineering, Kimi K2 is a powerhouse. On benchmarks like LiveCodeBench and OJBench, which test competitive programming skills, it doesn't just compete with giants like Claude Opus and GPT 4.1, it decisively outperforms them. And look at SWE-bench, which measures the ability to solve real-world GitHub issues. It scores a massive 65.8, leaving GPT 4.1 way behind. This is the direct payoff of that verifiable reward system.
Okay, but what about those agentic skills it was trained for in its virtual world? On benchmarks that specifically test multi-step tool use, like How2Bench and AC-Bench, Kimi K2 sets a new state-of-the-art for open-source models. This is direct proof that its agentic data synthesis and RL framework created a model that can skillfully and reliably orchestrate complex tools to solve problems. And its raw intellectual power is just as impressive. On GPQA Diamond, which is made up of graduate-level STEM problems, it tops the charts. And on the Amy Competition Math Benchmark, a notoriously difficult test of reasoning, it scores nearly 50, a level of mathematical ability that is just far beyond its peers. This is that knowledge rephrasing pipeline at work, building deep conceptual understanding. But, benchmarks are one thing. Real-world performance is another. And this right here is the ultimate validation. On the LMSS Arena Leaderboard, where thousands of real users blindly rank model outputs against each other, Kimi K2 is rated as the #1 open source model in the world. People don't just think it's good on paper, they actively prefer using it. And that brings us to the most important takeaway, our central thesis for today. Kimi K2 is not just another powerful model, it's a new blueprint. By solving the fundamental problem of training instability, the Kimi team has created a more efficient, more scalable, and more reliable methodology for building the next generation of agentic AI. This leaves us with a truly exciting question for the future. If this is the new, stable, and efficient path to creating agentic intelligence, what will the next models built on these foundations be capable of? What new frontiers will be unlocked when the brightest minds in the field no longer have to worry about the system blowing up? The possibilities, they are truly mind-bending. Thank you for tuning in and powering the conversation on the AI Innovation Online podcast. To stay ahead of the curve, visit us at AIinnovation.com.